Welcome back to another video of Leveling Up with Docker. In the last video, we talked about volumes. We learned about how to keep your data alive even when the container comes and goes. But here's the things. Once you start running more and more containers, you run into problems. Like, what if you want to run a database? How do you even set the password? You cannot just SSH into containers and edit the config file. So how does it work? Or something crashes and it will not start? Where do you even look to find out what went wrong? And when server reboots overnight, do your containers just stay dead? Or do they come back on their own? Then there is cleanup. After a few weeks of trying things out, you've got dozens of images sitting around eating this space. And stock containers just sitting there doing absolutely nothing. So today, we are going to learn how to actually manage your Docker environment. Not just run things, but manage them properly. We'll cover the environment variable so that you can actually configure your containers without editing files. We'll look into container logs to figure out what went wrong when something breaks. We'll set up a restart policies so that your containers survive reboot. And finally, we'll clean up these images and containers that you have been holding. Of course, last but not least, we'll do some exercise as well. Time for us to level up. Now, containers need configuration. The obvious approach would be to open a shell inside a container and edit the config file. You technically can do that, but that's not the Docker way. Docker manages its startup configuration via environment variable. Let me show you. I'm going to run a Postgres SQL. So what we do is we do docker run as usual -d rm name dt postgres -e postgres password equal docker -e postgres db equal to test db postgres. There's a space here. Docker run -d. What am I doing? Okay, I'm passing two flags here. The first one is Postgres password, and it is required. Without it, the container will refuse to start. The second one is PostgresDB. It creates a database named testdb on the first startup. You can verify these are the set environment by checking on the container environment. So let's do that. Postgres env grep why am I keep typing wrong thing? Okay, anyway, just do the exec, you run on dt postgres what we named before, then you run env. So you can actually get Postgres and you can see that both of the environment variables are set. Now, you might be wondering, how do I know exactly which variables to use? Actually, you don't really need to guess. Every official images on Docker Hub has documentation. Let me show you. So when you go to hubdocker.com/postgres, you can actually scroll down and you'll be able to see the section of how to extend this image. Usually all the environment variables will be actually documented here. As you can see, they say the only variables required is Postgres password. The rest are optional. Let's go back to our terminal. Now, the Postgres entry point actually read this and configure the database automatically. This is how real Docker deployment works. You don't SSH into containers to edit configs. You pass the configuration through environment variables. It is clean, reproducible, and it works the same on every machine. Now, let me show you about container logs. When something is not working, maybe your container will not start, a web server runs into errors, a database refuses connection. The first things that you should check is actually logs. Now let's run Nginx so we have something to show. Docker run -d rm name dt nginx. Okay, it is running now. So let's view the logs. dt nginx. Right, you'll be seeing all the logs from inside. What you want to check is basically here to make sure that the configuration is complete and it is ready for startup. If the Nginx actually failed to start, you would see some errors right here. Maybe it's missing file, port conflict, or maybe some bad config. Now let's see some of the real useful flag. One of them is actually a follow. So let me log into another screen here. Yeah, at the same time, let me do this, docker logs -f dt nginx. Right, so -f is actually the follow. So what it does is basically it'll follow the logs as it grows. So on the right hand side, is basically where I'm going to log in again to the docker ssh. Let me go inside. Then let me do a docker exec dt nginx, faithfully nginx curl -s localhost. Right, you'll see that as new logs appear, we are just keep following. So let me test.html. It'll tell you that there is some error here. There is no such file or directory. Right. So another one that I like to see here is basically sometimes I want to see like the last 5 lines maybe. You can actually do tail 5. Okay. But generally what I like to use is basically I always like to see like the last 20 maybe. Then after that I'll ask them to follow as well. So by doing this, you actually see like all the logs, like the 20 lines before, and start following the subsequent new logs. Right, that should be quite easy. So let me exit this, we don't need this anymore. How about next one? The next one is basically, we'll be talking about server reboots, right? So most of the time, sometimes every now and then after updates and things like that, right, you probably do a server reboot, right? Sometimes we do some updates, sometimes we just crash, right? Then what happens to the containers? By default, nothing happened. They just stay stopped. You have to manually restart them. Let me show you. So at the moment we have Nginx running. So what I'll do is I'll just reboot the machine, right? So let's reboot. Oops. Let's reboot here. Let's wait for a while. Time. It is properly rebooted. Okay. So if we try to do the docker ps, there is actually nothing. Right, so the Nginx that we ran before is gone. Now let me show you how to fix that. I'm going to run the Nginx again, but this time I'm going to start it with a restart policy. How to do that? And do docker run -d rm. the same of everything, nginx. The last one is restart unless stop nginx. See. Oh, sorry, I shouldn't use rm if I want to start it with nginx. Right. So that makes sense, right? So you try to actually restart unless it stop, we can't do rm, because if we do rm and we stop it, then the whole container will be gone. Right, let's reboot again now. So we do docker ps, we see this. So if I reboot again, right, so I do docker ps, you see that my nginx is already restarted. No manual intervention needed. So the nginx is just running again. There are a few restart policies actually. The default one is actually no, that means you'll never restart it. Then there is also on failure, right, which only restart containers if it exits with error. Then the one that we used before is unless stop, right? So it'll always restart it unless we specifically stop it. Then finally, there is also restart always. I don't really like this option because with always, Docker will restart the container right back up at the moment, even when you try to stop it. So it is kind of annoying. So you just like stop then restart unless you can actually do it fast enough, right? Of course, another way is basically you need to actually update the policy first, then you can actually stop it. Yeah, so that's why I usually just do unless stop, right? This is the sensible default for most of the cases. Now let me show you how to clean up. Every time you run a container with an image that you do not have, the Docker will pulse it. And those images sits on your disk forever unless you remove them. Let's check it out. I have run some cleanup before, so I don't have that many containers inside, but here you can see that I have a growing list, and some of this I'm pretty sure is not being used at all. So let's remove this container, right? So remember our hello world, I'm going to remove it, right? So how do we remove this? Just do a docker rmi hello world. Oh my, see that? It says that the Docker is used by a container, so we can't really use it. So docker ps -a, we'll see that there is hello world here. Although it exit, we are still using it. So what we need to do is docker is stopped already, so we can do docker rm hello world. Not hello world. Again, this is why I actually use a name before, right? So without that, we'll have all this difficult to to type container name, right? So after this, we will be able to do docker rmi hello world. Yep. So the same with the rest. So if you try to remove one by one, then it'll be a bit tricky, right? So what can we do to actually do it faster? So you want to clean just all the image all at once. So technically I can do docker image prune -a. Right. So if there is no association, they'll actually delete the images. Right. So like here, wow, just by doing this, I actually clean up like 300 meg. Now, what if you want to find out like what you have that is consumed by Docker? You can actually do a Docker system df, and you see the list of what you have, right? So you have like things like build cache, you have like local volumes, you have like containers. So I still have some little containers there, and we have some images as well, right? Now if I want to clean up everything going nuclear, this is actually equivalent to what we usually do, like rm minus rf kind of thing. So that is what we call Docker system prune minus a. So what this will do is basically they remove even the containers when it is not running anymore. So here we'll save some more space. So we do docker ps minus a. It is very clean. We are only left with our nginx. Right. So if I do docker image, I believe. Okay. We are only left with the nginx latest. Alright. Now it's your turn. Now, here's your challenge. I want you to run a MySQL container, test it, and configure everything properly. So here, I want you to run it with certain settings here, right? So I want you to set the root password as Docker, and you try to create a test DB, right? And I want you to start the restart policy. Start with restart policy called unless stop. Right, then I want you to do verification of the environment variables. You want to check the logs, right? You might want to run some connection tests, right, to show that our database is actually up and running, right? So you can pause your video here and work on the first part. I'll show you the solution when you're ready. Okay, welcome back. So let me walk through the exercise, right? The first one is we say we want to do a Docker run dt mysql minus e mysql root password docker. Remember to check the documentation so that you know all this environment variable. MySQL database go to test db. That's all we want. So I'm going to put restart unless stop MySQL. Why do I keep typing wrongly? Right, I want to unless stop. Remember, you can't do rm. Right, it should take a bit while. So as usual, it'll just pull all the images that we don't have because we pruned it earlier. Right, while doing that, let's docker exec dt mysql env, grab MySQL. Let's check if all our environment variable is being set. Yeah, in fact, they actually have some other environment variable that they set by default as well. Right, so let's check the logs to see what it says. Docker logs dt mysql. Yeah, we have quite a number of things here, right? So it says that init is ready for startup. So generally it should be fine. It should be running well, right? So let's connect it now. Docker exec minus it dt mysql minus u root minus p docker minus e show databases. Yeah, you can see that the test DB is actually created, right? So you can notice that I'm actually using docker exec to connect from inside the containers. I'm not connecting from the host because we have not set up any port mapping yet. We haven't set any networking yet. MySQL at the moment is only reachable from inside the container right now. We'll try to fix that in the next episode as well. You should see the information schema, MySQL, performances, and most importantly, your test DB here. Now, here's where it gets interesting. Let's go to the next exercise, shall we? So for the next exercise, I want you to actually pull a Cloud Beaver. Right? So this is actually a web-based MySQL management tools. So when we pull this, I want you to run with a container name dt Cloud Weaver, and restart policy set the same thing as well unless stop. Right? Then once it's running, I want you to check the logs and yeah, see, can you actually access it? Okay, you can pause again here and try to deploy it yourself. I'll show you the solution when you come back. Welcome back again. So let me deploy the Cloud Beaver. So docker pull beaver Cloud Beaver. Okay, actually I don't need to pull first. I'm just showing you like technically you can actually prep it first. So if you do a pull before, then the next time when you run it, it'll be faster because it doesn't need to pull anymore. So while this is running, I'm going to type some of the command already. sd name dt Cloud Beaver restart unless stop beaver Cloud Beaver. Right, it's running. So we can do docker logs dt Cloud Beaver. Yeah, the server seems to be running fine. But here's the question, what can we do about this, right? Technically, we still can't access the Cloud Beaver using a web browser because there is no port mapping. And even if there was, the Cloud Beaver still can't talk to MySQL container. They are at the moment on a separate networks, completely isolated. So right now, you actually have a tools that nobody can access, pointing to a database that it cannot reach. Cloud Beaver is literally useless right now. So we are going to fix that in the next episode. We'll try to connect these containers and set up networking properly and finally get Cloud Beaver talking to MySQL. So that's what Docker networking is all about. Now let me quickly recap what we covered today. First, we look at the environment variable. This is how you configure containers without ever touching the config files. You just pass the settings on the startup and the Docker will handle the rest. Then we use container logs to see exactly what is going on inside the containers. When something breaks, the logs are the first place that you should look. The follow mode is extremely useful for watching things when happen in real time. We also set up the restart policy so your containers survive reboot. A simple flag and they come back on their own. No manual intervention ever needed. So finally, we also learn how we can clean up all the unused images and the containers that is eating up your space. A quick prune command and you get back all that wasted space. Feel free to pause this screen and take a screenshot of the commands for later. Okay, if this video helped you out, hit the like button and subscribe. It really helps the channel grow. If you have questions, drop them in the comments. I'll try to read and answer every single one of them. The next time, we are going to make Cloud Beaver actually useful. We'll connect your containers and set up the networking properly. And finally get everything talking to each other. See you in the next one. Goodbye.